You may start. Thank you.
Hello everyone. Just introduce myself briefly. I'm Ziru, a student from University of Manchester, and my research interests including ESG, about facility management, also about artificial intelligence, for example, for Bayesian Deep Learning. Yeah, and this research is about Bayesian Deep Learning few short whole life cycle about the decision making strategy development. Yeah, and first of all, here is about background. Yeah, the background about the early stage whole life cycle life causing estimating have made very few short about some local project. Here some local project cannot be compared. Also, ESG factor cannot to be monetized as money. Yeah, and also there are popular cost estimation is about the single point estimation. However, they haven't given a range for some risks. Yeah. So here we can see the method I have proposed about based on the NASA national infrastructure. Yeah, this department and develop this model to adapt with the Bayesian deep learning model, and also using a small local example for Manchester City. Yeah, and my output is about the address risks, whole life costing, benefit cost ratio, and also the red, amber, and green classical class for the risks structure. Yeah, and here is my aim and objective to provide the UK cost engineer with a tool to evaluate the building project portfolio to develop and deliver the most practical uncertain welding cost prediction. Yeah, and here is my overall Bayes whole life cycle workflow. Yeah, first of all, I have identified the scope and the rule, and then to get the data from NASA public data set, and then to catch up the ESG feature and normalize, and also I use the literature for the shadow price to monetize and quantify the ESG factor as the cost. Yeah, and then just validation for LOOCV and also for underside scientists, and use the few short adoption for Manchester City Council data and develop this model. Yeah, and then I just show my result as soon as possible. Yeah, and first of all, here's my result for few short learning and reflection for that. You can see from 10 example, the efficiency is remain very stable. So in this term, I can say this just efficiency just decrease from after 10. Yeah, and the second one, because I have also quantified the ESG factor as the financial cost. So also I have identified the risks from a very single and subject from risks adjust from green about 100%. However, now it's diversity from green, amber, and red about 5.1.2. Yeah, and also I have calculated and recalculate develop the benefit and the cost ratio have some different. Yeah, the ratio is much more improved because I have calculated the ESG performance as the benefit for the cost. Yeah. However, for current cost estimation practice, they just use the financial. Yeah, what's the return for financial about investment? What's the income for that? However, I just address for example for environmental standard for the ISO standard and also for net zero 2015. Yeah, and the third one, yeah, is about the ESG body. Is made very clear and about policy aware. Yeah, for example, I have compare and calculate the cost and risks. For example, for carbon emissions, what's the carbon emissions means? For example, for carbon tax, energy waste displacement, and also for other risks. And the benefit also use for example, what's the implication for improvement for local community, and also what's the policy for shadow price library. I have also developed a shadow price library, for example, for for carbon price, for the policy public opinion price to that. And also here in the end also about the public, PS 2018 scenario about the CAPEX is about the this number, and also monetize the independent ESG costs, and also address with the risks for whole life cycle costs for, and also with my unit of analysis is about infrastructure, and also here is about overall for industry for CAPEX from for example for different sector, from energy, from water, from house, from transportation, education, and also in the right side is about the different region. For example, for South, for England, Wales, and also about large about UK government, and also conclusion that energy dominant is determine the settled CAPEX distribution, and also offshore and England cut a large share of reporting regional export. And for the government's implication, portfolio management needs the risk addressed field before confirming the resource decision management for structure. And here's also about the robots and operation. So we can say this is very strong and can cover in a local example. And however, here also there are some drawbacks. For example, for largest degree come from removing the presentation. However, for ESG benefit, maybe just post very too positive in this research. And the conclusion here, first conclusion is for methodology. I have contributed with the national priority for deep learning plus the Bayes last. However, I have just phrased the Bayes natural network for a national plus and just use this in local communication. And also for government level, I also propose with the risk address the whole life cycle costing, and also for benefit cost and radio, and also red, amber, and green risks sure for gray fuel. And for practical address to identify and quantify the ESG costs. However, limitation is about a single UK government sector, just about limited data set, just use very general level data. And the shadow price also should be developed furthermore, because it's just about developed from HM treasures guidebooks. And also in the future, just about this way, I also will conduct with some expert in the field for that. Thank you for your listening.
Okay, thank you. Good timing. So can I invite